Hello everyone, and here I'm started tuning this deck. I tuned it azimuth as I told you in previous part, and now I'm just tuning it speed. It was 2980. I was able to get 3001, 3003 range. Unfortunately, port is too sensitive around 3000 Hz, and here you may see wow and flutter. It's 0.035 to 0.04%, which is pretty good for the stick transport, so low wear, and good results for this deck. Alright, now I will be preparing to start tuning procedure. I'm already opened the service manual, so let me go to the levels. Here are the boards. I will be using this shot. It's page 7, where all ports are signed, and you see test connector. I'm just connected the test device to this connector, so we would be able to operate and control the CPU of this deck. And here is more ports like on the lower board and on the bias and power supply board. Alright, let's move on. Tape speed I just adjusted, so we have it proper. Meter level I did it, but we may check together with you. Alright, so oh no, we need to check meter level. I was checking the tape level, so it will properly show levels. Alright, give me a moment to connect AC voltmeter to the test point, so we would be able to verify that we should have 350 millivolts, and then we will adjust ports to show zero level. See you in a moment. Alright, and here I'm back. I set up so 2 probes connected to the TP test points on the boards, and I set up the volume to show like 350 millivolts, so range is 1 volt, and we see 350 millivolts, and I didn't touch anything. It shows 0, so it's pretty fine. So this step is validated. However, while I was looking into that, I mentioned that someone was soldering this connector just in place. Well, guys, if you do that, it's preferable to pull up connector inserts, and then solder them and install back, because those are from metal, and you would not harm the plastic. All right. So next would be MPX filter step. So I will put 19 kilohertz. All right, I have 18. I might do 19 from the other generator. Let's see how it will perform here. Connect AC voltmeter to the output jacks. Monitor source, MPX on, and obtain minimum reading by touching these coils. Alright, so probably I need to connect the 19 kilohertz from this generator, and it would be more fair, and these 2 coils sits right there. Let me prepare and I will show you. Alright, we have signal. I'm feeding 19 kilohertz, and we have signal on the output. Now I push MPX button. We have MPX filter sign lead here, and we have signal gone. So it's without, that is with filter on, and now I will use, so we have 15 millivolts only. Alright, and I will be using screwdriver to touch these 2 coils, 101 and 21 for MPX filter, to get the minimum readings, you see. Alright, so that's 1, And that's the other one. You see? So they are in proper position. Works really well. All right. So that's how MPX filter works. Now, that's where we just completed step number 3. MPX filter adjustment verified. Now, BS oscillation frequency. We need to obtain 105 kilohertz. So let me connect oscilloscope, prepare, and I will meet you there. All right, I connected the probe to the rise head, and we measure 104.6 kilohertz. All right, so I need 2 hands. Let me adjust it, and I will show you the final result. All right, and here we have 105 kilohertz. Considering how long this deck was not tuned, for about 40 years, it keeps parameters really well. All right, next step. I would not be checking rise current because it's required to find 0.1 ohm resistor and attach it to the coil and measure. I believe it should be fine. From my practice, this never been significantly off. All right. Next one, BS trap adjustment. We need to connect voltmeter to TP 103.203 and adjust coil 102 or 202 to obtain minimum reading of the voltmeter. All right, here are our points, right, and here is the coils. All right, let me connect and let's see. All right, I connected the right channel right here, you may see, and we will be touching this coil here to find a minimum reading of these values. So it's growing. All right, if something is wrong, I believe we need to use coils, not 103 and 203, but here, these coils. Let me see one more time. Coils 102 and 202, all right? And these coils here, 102 and 202, these 2 coils. Connecting opposite channel. All right, let me connect milliwatt meter so I'll be able to see it better. Just a moment. All right, here I am attached both probes to left-right channel. We see them both on the oscilloscope, and we see the level on the milliwatt meter, and these 2 coils we will be turning on to find the minimum values. So you may see that it changes, right? And here it changes one direction and another direction. So we set the minimum and keep it here. And now the second channel, I will be doing the same. So this direction grows, rotates in opposite direction, right, it grows. So that would be the minimum. So it was set properly. We just verified that everything is correct. Next, we will have to connect our probes to these 2 test points here, 104 and 204, adjust these 2 coils to get maximum readings. Stay tuned. Let me reconnect. All right, guys, I connected still to these points. I have a frequency now, it's bias, and here is the values. And I was adjusting these two coils, so technically return them back, because these two coils we just reach the maximum value and stay here. It goes from like lower level to here and then stays on this value. So technically you should not touch them, as they were like pretty fine tuned. And next step would be a recording bias adjustment. Okay, let me prepare, read through the procedure, and I meet you there. All right, now we will be tuning. For this step we have to install tape ZX or metal tape, connect the milliwatt meter to test points 104 and 204, did it. Next step, turn VR 103 and 203 fully clockwise, and these two ports for metal bias. Alright, so we will be tuning them both fully clockwise. One and the other, right there. Alright, so we have values. Next step, connect test unit, click test max. Right, test max, done. Now adjust VR 104 and 204 to obtain 80 millivolts. Okay, 104 and 204, these two are in the middle. Alright, need to obtain 80 millivolts. So there's one channel, you see one channel was off a little bit, so let me connect. And it's degraded over time, so we have to set 80 millivolts. Alright, next return 103 203 to the mechanical center. Alright, that's the one. And the other one. Oh, yeah. Next step, adjust 605, 607 to obtain 70 millivolts. And 605, 607, these two are on the main board. So these two guys right here. Let's obtain 70 millivolts. So that's the one. And that's the other. All right, 70. Next, test minimum. All right, test minimum, done. Adjust 604, 606 to obtain 25 millivolts. We are pretty close. So 604, 606, these two guys here. So need to adjust to get 25 millivolts. Right there. Now we have both even. Perfect. Repeat steps 1-2 times. So let's see. Test maximum. We have 70. Test minimum. We have 25. Perfect. Now test center. Test center. All right. Change cassette tape to SX. All right. I don't remember exactly. It's I believe it's probably chrome tape, right? Let me see if I install normal. Yes, go to EX. So we need chrome tape here. Let me install chrome tape. Click record. And we should have EX tape displayed here. EX, good. And adjust VR 101, 201 to obtain 13 millivolts. And 101 and 201, these two, no, 101 and 201, EX. Why is this EX? Let me see. For a second, 102 and 202, obtain 20 millivolts. Alright, this two in the middle, and we're pretty close. Let me see. Just one channel, a little bit less. We have 20 millivolts, good. And now install EX tape and adjust to 13 millivolts. Okay. I will switch to 30 volts, so we will see it's 14 and a half. And we need to get to 13. Exit one channel. And the other channel. Now it's good. So click test button twice and we will complete this step. Done. Good. So you see, it was close, a little bit off between left-right channel. But what we learned is that the adjustment optical relays still work good in this deck. Remember the one I was testing before had an issue and I had to adjust amplification levels, right, with the additional pots. So if you will meet this problem and it would not be showing you proper values on the milliwatt meter, then you may refer to my video and see how to overcome this problem with aged optical relay. Okay, next, AD converter. We need DC voltmeter to test point 301 on logic board. Let me connect it and I meet you right there. All right, here I connected to the ground and to the test point 301, and we need to use test max position, and we should have 2 volts here. It's pretty close, and this port is responsible, so we just need to adjust a little bit to get 2 volts. Done. And next we need to click test center position. All right, and adjust port to get 1 volt here. And this for our analog to digital converter sensitivity. All right, 1 volt, and now we will repeat a couple times. Maximum is 2 volts. Center 1 volt. Perfect. Good. So this step is complete. Step number 7. Next one will require adjustments of the different ports. Let me connect and I will meet you right there. So next step, we connect to test point 105, and now we need to click test OSC button. All right, and we need to click auto calibration button, and it shows level here. All right, level indicator lit up, adjust VR303 to obtain 1 volt on the DC voltmeter. But I don't see anything here for some reason. How is possible? Should be 1 volt. And both test point don't show me anything. So something is wrong. Let me check it because I see level lit up here. Maybe I'm doing something wrong. Okay, it's test points 105 and 205 on the logic PCB. That's the points I'm using, and currently both of them don't show me, and we need to use DC voltmeter to the test point 105. So everything is correct. Let me see. If you click on the switch to bias, and still nothing here, and nothing on the other test point. Alright, let me figure out what I'm doing wrong. Technically it should work. See you soon. Alright, I figure out. So I forget to turn on react pause, and we need to switch to the source mode. Now level shows 0.94, which is low, and to get this we need to pull up this board. Unfortunately, to get to the ports right there, those two. Let me see, 3 or 2 and 3 or 3. All right, and these two right here. Yes, 400 gears and 15 kilogears. So I will be adjusting like right there, 400 gears, and we need to get 1 volt. Perfect. Now I will click on the calibration one more time, switch to bias. We should get 0.93 to 0.94 volts. All right, 93, 94, good. Now let's check again level, 1 volts, perfect. Now we connect to the second test point here, and we see a little bit disbalance. We need to use P301, which is right there below this board. Test on balance, right here. So this one. All right, and we need to make it 1 volt either. It's pretty close. Good. So, and switching bias 0.93. Okay. 1 volt. And checking back on the previous channel. And we have 1 volt. And we have 0.93. Perfect. Good. We just tuned it BS oscillator, not BS, calibration oscillator. So these 2 test tones, we balance it between left-right channel, and we set proper levels for 15 kilohertz and 400 Hz. Next one, my level controller gain adjustment. I need to reconnect. I need to set 400 gears to the input jacks, connect the voltmeter to the points, and check it. Alright, give me a moment to do that. Alright guys, I'm prepared. So I'll connect it to the pin 4 and 5, 2 channels, and we have voltage on the output, as you may see. Right, so I put into the source mode, 0 decibel here, and we feed in 400 gears from the generator, into the deck input here. All right, everything is described as this instruction. Now we need to click test center and remember reading on these pins, and then connect to pin 2 and 1 and adjust 105 and 205 to obtain the same level as on pin 4 and 5. Okay, so click test center, good, and level is like 295 millivolts. You probably better see here, yeah, almost 300. I can adjust left right channel a little bit to make it even, right, so it would be easy for us. 300 even in both channels. And now I have to reconnect this to the pin 1 and 2. Come on. I would say this is far off. Let me see. Test minimum. Test center. Not far off. It's close. Sorry. We should get 300 millivolts. Adjusting these 2 ports right there. So you see it's been off between left right channel. I cannot get it to the proper position, so I will have to make them even between left right. But you see there was the degradation of the optical relays, so the maximum I can get from one of them is like 10% lower already. Alright, but at least I will keep them even so it would be able to adjust it properly. Alright, so let's see how it will work now. Test maximum, okay, test minimum, test center. All right, it's look more or less fine. Let me try to adjust a little bit more. More precise, left, right. All right. Now we know. That's the best as we can do with this deck. Otherwise, like to make it even more precise, we need to install adjustment ports, which will change the amplification level for this op-amp here. And in that case, we would be able to tune up to this additional 10%. But if you will see schematic, so technically it still will adjust level to the proper value. The point is to have the range, so it would be able to do it. Then we have the range and it's fine. Okay, playback head azimuth center adjustment. Fine. Stop mode. Position. Port into the middle position. Done. Connect test unit to the logic PCB assembly. Done. Press test center. Test center. And we have it on the center. Right here, which is perfect. So we don't need to adjust the potentiometer mark here. Next, play mode. Right. Through mechanical center, test azimuth, and adjust so the red indicator lights up. Okay, let me install the reference tape. Play mode. Okay, test azimuth. Okay, and now we need to adjust. Let me remove this. Because port is right here. 608. Alright, 608, yes. So we need to turn the spot to make sure that azimuth indicator will read here. No, it's ready. Should it ready? Yes, ready indicator should read this one. Now we have azimuth. Good. See here. Ready indicator lights up. Okay. Azimuth indicator adjustment. Connect test unit. Press test center. Adjuster 609. Test center. And it's on the center, so we don't need to adjust. Good. Test maximum. All segments read. And then test button twice. Done. Good. Playback head track and azimuth alignment. I already did it. No. This one 1 kilohertz and 15 kilohertz tape. I see what's made to the upper jeffs. Play. Hit gear playback head azimuth alignment. No, I did it. So we good. Playback level calibration, I did it already. We may check. So I will use a different test tape for this purpose. And it plays zeros, as you may see. Alright. So if you would need to adjust it, it's 2 ports on the lower board, and they sit right here. These 2 playback level. Alright. Next, playback frequency response. That's what we need to do. Put tape with multiple frequencies and connect. Tape play it back, adjust control obtain 0 dBV, 1 volt, load tapes, align playback at azimuth, check maximum levels are within the range given below, minus 20 decibel. So technically I'm already did it, so let me reconnect because I would love to do it with T100 analyzer. All right, and I will meet you in a moment. And here I'm back. I'm connected my T100 analyzer. So we have 0 levels on the input, so it would be quite easy to see the levels. Now I'm playing and switching to the tape mode. And what we need to check that levels from this tape would not be changing over the whole range. So let me turn on spectrum. It's 8 kilohertz and goes down. So levels should be in range like 1-2 decibel, not more. See, it's 2 kilohertz, 400 I believe, right? And now it goes up and it still keeps level, pretty fine. minus 13 and minus 12 decibel, considering this range. And it's 10 kilohertz now, and it keeps pretty well. And it's 12, 13, 14, and 15. You see it adds plus 2 decibel. So heads are in perfect shape, and amplifier is pretty good. All right, we should be good here. So we check it, frequency response, record height adjustment, and azimuth. I'm already did it. So technically, phase comparator adjustment, I believe you already did it. Rec play mode, adjust to... Alright, let me check this one and record level, and I will meet you soon. Alright guys, to complete this step I need to load metal tape, set record play mode, click test center, adjust azimuth of the record head, right? So let me show you. I will show like on 12 kilohertz, for example. That azimuth is good. Okay, then set 400 hertz. Right, so we're recording 400 hertz. Set the level, and next we have to adjust this VR304 phase comparator so that the azimuth indicator lead, and you see it's was lit, and it just goes out. Right? Right, adjust it. Come on. Let's me try to find maximum point. Right. Now it keeps all the time. You see, right here, azimuth. And I was adjusting this spot right here. Right, now it keeps well. That's completed. Record level. Set test unit, tape 400 hertz. Set the monitor selector to tape. Press test level. Okay. Test level. Done. Monitor to tape position. We are on the tape. Good. We need. Okay, record. We need to click auto calibration button when auto calibration is completed. No. Okay, it's completed. So we're recording, and now we need to adjust 101 and 201 to have the same level as on the source. Okay, and these two guys here, and we are a little bit lower. So as the source, that's the tape. All right, so need to pull this board up and adjust these two ports right here. That's one. And that's the other one. Okay. Now if I will switch source tape, nothing changes. And that's a perfect. That's what we expected. Next, insert a sex. After calibrate and repeat for the sex. I will use TDKSA tape for that. Alright, so we will repeat procedure. Calibrate. Ready, and we're recording, and let's see levels. Right. It's a little bit lower, so just in one channel and the other channel. Good. So source tape, we are even, and the last one we will repeat it for the simple normal tape. All right. Automatic calibration. And we're recording. And levels are pretty close, so it was tuned pretty well. As you've seen, we just had bias difference between left and right channel, and had been off on this deck. Someone was trying to play with it. Alright, so we completed levels adjustment, record amplifier equalizer adjustment, give 23 kilohertz to input jacks, connect voltmeter, and adjust two coils to obtain pike level. So these two coils here. So we need to adjust so it will be piking. You may watch my other video how I do that. It's pretty simple. Alright, we've done. Let me complete this piking. I need to reconnect again. I need to get my signal generator to get 23 kilohertz and adjust it. See you in a moment. Alright guys, now when we completed tuning, let's do full test. So let's do calibration, and it's ZX tape. Alright, we are calibrated. So as source mode, and I have minus 20 decibel. Okay, here you may see up to 20 kilohertz. Let me scale in so you would see it a little bit better. So that's the source, right? Shows pretty well. Some reason drops right here. Some filtering. Let me see. Oh, MPX off. Here, if I will use MPX, it will cut off somewhere on 14 kilohertz. Alright, now I'm starting recording. And switching to the tape. Here is the tape. Very well. So source and tape, and it's metal tape. Okay, now let's see minus 10. Super well, you see, very linear to 20 kilohertz. Minus 6, and it holds, see? Cool, and zeros. It's almost there, a little bit like 2 decibel over. Perfect results, perfect tuning. Hope you enjoy it. Now you can repeat this procedure yourself. You know how to do it. You may follow my steps and you will be good. So see you in my next adventures. Bye-bye.